Hi Helena, I got your email about graphing asymptotes for quadratic over linear, so I'm going to look for that topic in my student account and we'll look at how to graph these asymptotes, quadratic over linear. So you mentioned the topic is called graphing a rational function, quadratic over linear. So that must be this one. Okay. I'm going to go ahead and get started on this. Oops. Okay. So the function is f of x equals x squared plus 10x plus 4 over 2x plus 4. I'm gonna first try to simplify this to find if it has any hole, but I'm looking at the numerator. X squared plus 10x plus 4. That doesn't look it's not factorable, right? Because the only number that multiplied to be 4 is 1 times 4, but they don't add up to 10. And 2 times 2, and they don't add up to 10. So the numerator is not factorable, so it's not going to have any hole because it's not going to cancel out with 2x plus 4, or I guess at least I can simplify or factor the denominator, make it 2 times x plus 2. Okay, so I have a vertical asymptote where x plus 2 is equal to 0. If I subtract by 2, I get x equals negative 2. So I think you're okay with graphing that. I can just graph x equals negative 2, but what if it's a decimal, or what if it's a fraction, right? If that's the case, how can we do that? I'm thinking that we just go like halfway point. So your question, one of the question was, how do you graph negative 1/2? If that's the case, not for this problem, but if I were to graph negative 1/2, I will just go in between 0 and negative 1 and just put the vertical line right there. But I actually have what? Slant asymptote in this case, so I can show you that linear case, okay? All right, so to find the slant asymptote, I will have to do division. I will do x squared plus 10x plus 4 divided by 2x plus 4. I'll do long division, okay? If I do long division, I'll put x squared plus 10x plus 4 inside. I put my 2x plus 4 outside, and I start dividing. What is x squared divided by 2x? I like to do this work on the side. What is x squared divided by 2x? X squared is 1x squared. So if I do this division, I will get half times x. So half x will go up here. And then I must now distribute this half x to 2x times 4. And I'll put that underneath, okay? So let me go ahead and put that. That will be x squared plus half times, 4 times half x, that is 2x. And then I'll subtract these two lines. If I subtract, this x squares will cancel out. 10x minus 2x is 8x. And I'll bring down this plus 4. All right, now I'm going to divide 8x by 2x. 8x divided by 2x is 8 divided by 2 is 4. X divided by x is just gone. It's 1. So I'll put the plus 4 up here, and I'll multiply this 4 to 2x and 4. And now honestly I can stop here because I got what I need. But if I try to finish this up a little bit, I'll have 8x plus 16. And then if I subtract on one second. My dogs came back. I have to go open the door for them real quick. Oh, what is this going to be? 4 minus 16. Is that going to be negative 12? Yep, negative 12. But when you are doing the slant asymptote, the answer is just going to be the quotient. So this is what we want to graph. We want to graph y equals half x plus 4. And I have a strong feeling that you are okay with this. You know how to find the slant asymptote. It's just a matter of graphing it then, huh? Okay, let's go ahead and graph half x plus 4. So when I'm graphing this linear function, I will go ahead and click on this. Well, let me go ahead and plot some points first, okay? If I plug in 0 in here, wouldn't that be 0, 4? Well, the y-intercept is at 4, so I plotted the 4 here. Next, the slope is half over 4. And you know, guys, you can use your y equals mx plus b. But if it's a linear function, you can just plot points. You can just plot 2 points. If I plug in 0 in there, I'll get 4. What will happen if I plug in 2 in here? Half of 2 plus 4 is 1 plus 4, which is 5. So I will plot 2, 5. 2, 5. And 2 point is all I need, really. And then I'm just going to go ahead and grab this and do lines like that. All good. But they wanted us to start by drawing the asymptotes, which we did. Then plot 2 points on each piece of the graph. Finally, click the graph function. Now maybe I will delete these dots because I want to save these pencil marks for my rational function. So, okay, I got my asymptotes graphed. So what I now need is at least 4 points. I need 4 points, 2 to the right of the vertical asymptote, 2 to the left of that vertical asymptote. So the vertical asymptote is at x equals negative 2, right? All right, hold on. I'm going to plug in 2 points to the right of negative 2. Numbers that are bigger than negative 2. I'm going to use 0 and 2. Just random, they're bigger than negative 2. So if you see negative 2 is right here, I can plot 0 and 2. They'll be good looking points. So if I plug in 0, what will I get? Remember the function was x squared plus 10x plus 4. The bottom of the function was 2x plus 4. Let me plug in 0 in here. That is 0 squared plus 10 times 0 plus 4 divided by 2 times 0 plus 4. That is 4 over 4, which is 1. I will plot a point at 0, 1. 0, 1. Next point, I plug in 2 this time. 2 squared plus 10 times 2 plus 4 divided by 2 times 2 plus 4. I'm going to type this into my calculator because it is 6:49 in the morning. And who knows what kind of mistake I will make if I'm not careful. Alright, hold on. If I type that in, 2 squared plus 20 plus 4 divided by 4 plus 4 gives me 7 over 2. Hey, I wish it was a nice number. It's a nice enough number. I can plot using this function. I can do 2, 7 over 2. My dogs are scratching the door. I must pause the recording for just 1 second. Alrighty, I came back. So let me now do 2 more points to the left of negative 2. Numbers that are smaller than negative 2 are maybe like negative 3 and negative 4. So I'll plug in negative 3 and negative 4. Okay? How about I erase this because I already have the points plotted. Okay? I like to use this table again. So this time I'm going to plug in numbers that are smaller than negative 2. Negative 3 and negative 4. If I plug this in, I have to be careful because the number is negative this time. Alright, let's do this. And maybe Helena, you're not even watching this part because you're probably okay with graphing on the rational functions part, but I like to finish this up myself to see if I can get this right. 2 times negative 3, that's negative 6. I'm typing this into my calculator. Ew, 17 over 2. That's okay. I like how ALEKS has this one tool for me. Plot a point anywhere. So I can type in negative 3 And the other fraction is 17 over 2. Plot that for me. It's up there. Okay, I need one more. So I need exactly the same, but I'm just gonna plug in -4 this time. This topic takes me longer time. It's not hard, it's just tedious, isn't it? Like a lot of things to do. Hey, at least it came out to be a super good looking point. -4, 5. So I'll plot, go 4 to the left, go 5 up, plot point. I'm done. I'm gonna go ahead and click on the graph function like this. Ta-da! Oh, okay. Something looks off. As you can see, this shouldn't happen. Like, what in the world is going on? You see it's curving up like that. I think I did something wrong. I'm going to fix the point to 17. Okay? I'm going to plug in 2 one more time into this function because I don't believe this is true. See, it's curving up and it's going over it, right? That doesn't look good. Okay, I'm going to start over again. I don't think this point is right. 217 over 2. So let me go ahead and try this one more time on my notepad. So what will happen if I plug in 2? Because I think that was a mistake. Okay, let me see. If I plug in 2, that will be 2 squared plus 10 times 2 plus 4 over 2 times 2 plus 4. I'll change this now, okay? When I type this in again, I got 7 over 2. So what I'm going to do is I'm going to plot 2 and 7 over 2. I cannot remember what I got last time. 2 and 7 over 2. Okay, I'm gonna try again now. No, I don't agree with this. I don't think I think there's something wrong with this because of this curving. But I did everything right for the 2. Maybe it's this one. If I plug in 0, maybe I did it too fast and I missed it. Okay, let me try the 0 one more time then, okay? So I'm gonna keep the 2 and 7 over 2. This is some real-time struggle. Okay, and now I'm gonna plug in 0 this time. What is f of 0? That is 0 squared plus 10 times 0 plus 4 over 0 plus 4, right? Which, well, 2 times 0 plus 4. So wouldn't that be just 4 divided by 4, which is 1? I will plot a point at 0, 1. Didn't I? I can't even remember if I plotted a point at 0, 1. Okay, maybe I can watch my own video later. I'll go ahead and click on the graphs. I'm very upset now. What did I do wrong? I can't tell what I did wrong, Helena. I wish I can hear you. Is my intercept wrong? Oh, I think so. My graph doesn't look good. Because I'm supposed to have a point at 0, 4. Oh, I think it's not my graph. I think it's the asymptote, because you remember how the asymptote has to be y equals half x plus 4, right? And it's not really touching 4, so I think that's the mistake. I'm gonna go ahead and fix up my what's it called? The slant asymptote. Okay, so if I want to graph the slant asymptote, I will plot a point at 0, 4 first. And then next, I will plot a point at 2, 5. And then I will go ahead and draw a slanted line, starting at 0, 4, going up 1 over 2 to the right. and then I will do the graph of the rational function. Maybe, I think I did learn a new tool just now. The reason I'm thinking that my graphs were messed up because my asymptote was incorrect when I first graphed it. So it's okay to have pencil mark on both the asymptote and the rational graph, function graph. And I feel pretty confident about this. Let me go ahead and click on check. What? It's driving me nuts. Okay, so what did I do wrong? Will they show me? Maybe if I delete these pencil marks on the... I'm gonna get rid of these pencil marks. And then just do the graph. I'm not really changing anything, it's just getting rid of these pencils. Recheck. Oh, it was a little silly. So I learned something new just now. Don't be plotting those pencil marks on your asymptotes. They don't like it. They want you to just use the pencil mark for the rational functions graph. So you saw how it was exactly the same thing, but they marked it wrong when I plotted points to graph my linear function, my slant asymptote. And when I get rid of those pencil marks, they were happy with it. So that was good. Maybe I will just graph the asymptotes on the next one. More practice. All right, first of all, the vertical asymptote is at x equals positive 2, because if x is positive 2, 2 minus 2 will give you 0. So I'll plot it right there. Okay, what's next? I need to find the slant asymptote. So for this one, how about I do synthetic division, okay? Just do it real quick. This was okay. So put the negative, positive 2 in the corner, and I'll have negative 1, positive 3, and 2. Now do my synthetic division. 1 comes down, multiply and get negative 2. Add them and get 1. Multiply and get positive 2. Remainder is 4, but slant asymptote is at negative 1x plus 1. So, without using the pencil tool, because ALEKS will not like it, I will have to start at positive 1, because the y-intercept is positive 1, and I need to go down 1 over 1 to the right, because the slope is 1 over 1. Negative 1 over 1. Okay, now what? I kind of want to do more. Yeah, why not? Let me finish this up. So the graph is f of x, or the function is f of x equals negative x squared plus 3x plus 2 over x minus 2. I need to have 2 points to the right and 2 points to the left of this. So 2 points to the right was bigger than positive 2, because x equals positive 2 is the vertical asymptote. I can think of 3 and 4. These are just bigger than 2. So if I plug in 3, let's see what I get. Two. So very nice point. I'm going to plot 3, 2. And plot 3, 2. And another one, if I plug in 4, it's going to go a little bit faster because I typed up something similar in my calculator. I just need to go up and change the number 3 to 4 this time. When I evaluated that, I got negative 1. So 4, negative 1. 3, 2. 4, negative 1. Okay, I need 2 points to the left of this. Vertical asymptote of x equals 2. So what is smaller than 2? 1 and 0 are. So if I plug in 1 and 0, I get negative 1 squared plus 3 times 1 plus 2 divided by 1 minus 2. Okay, hold on, I'm typing this in now. I got -4. This is a much nicer problem. 1, -4. And I'm confident that we will get this right this time. Okay, one more. I gotta plug in 0 this time. 0 squared plus 3 times 0 plus 2 over 0 minus 2. I don't need a calculator for this. I will get 2 over -2, which is -1. So let's plot 0, -1. 0, -1. And then I'm gonna go ahead and do my graph. Voila, looks beautiful. And I'm gonna click on check. Yay! So I think I learned something new just now. When I'm graphing this rational function on ALEKS, I should not be using the pencil tool to sketch the asymptote. When I got rid of those pencil marks on the slant asymptote and only on the rational function itself, then that's how we got this question right, okay? I hope this was helpful. It was a longer video than I expected, but hopefully if this wasn't answering your question, because I think you were asking for how to graph these asymptotes, I want you to write me back so that I can try something else for you, okay?